If I was only ever allowed to explain one climate science topic for the rest of my life, it would definitely be about the difference between weather and climate. And while I think most people can intuitively tell the difference, it still surprises me how many people are still a little fuzzy on the details. For example, I'm Canadian and I'm a climate scientist, and every single winter, without fail, I have at least one person come up to me and point out that it's like snowing or that it's like colder than usual, kind of trying to imply that climate change isn't that big of an issue. And while they're always just kind of like these lighthearted jabs, and I don't take them too seriously, there's certain instances when you really want people to know the difference. For example, take this senator from the United States.
In case we have forgotten, because we keep hearing that 2014 has been the warmest year on record, I asked the chair, you know what this is? It's a snowball. And that's just from outside here. So it's very, very cold out, very unseasonal. So here, Mr. President, catch this.
I mean, it was kind of cute how he did all that, but when you remember that that person is in charge of making laws and legislation, especially around climate change, you really hope that they have a strong understanding of the difference between weather and climate. And I'm going to do just that in the first video of my new series called Science by the Level, where I explain a single science topic at 3 different levels of understanding. The first level is going to be the basics, and this level assumes that you don't have any prior information about the topic and is really good for students or anyone who's just too busy to really dive deep into these issues. The second level is called informed, and this is good for people who have a rough understanding of the topic already but are looking for something extra, so that you don't end up in the same situation as the senator where you think you know what you're talking about, but you don't really. The last level is expert, and this assumes that you're a smart cookie. You already know what you're talking about. So it holds no punches, gives you the full academic treatment. But it's not just for those kind of people. I think it's still relevant to those who aren't experts because it offers really good context. Specifically, it tells you not what we know, but how we know it. And that's really good because that context matters in many situations. So what's the purpose of explaining the same topic at 3 different levels? Well, other than padding my view time. It helps me solve this problem that every science communicator has, in that I don't know what my audience knows. If you're a student, for example, it's not going to be helpful if I jump off the deep end and start talking about all the complicated things. Oppositely, if you know what you're talking about, it's not going to be very useful to you if I oversimplify. So I hope that if I can explain a topic at 3 different levels, I can offer more value to you as the audience, regardless of what level of understanding you have. So with the why established, let's go back into describing what the difference between weather and climate is. But before we do, my name is Matthew. These are currently collecting a lot of dust, and you're watching Carbon Anonymous. So weather can be defined as the state of the atmosphere at a particular time and place. And it measures things like temperature, rain, or even just cloudiness. So when we say weather, you should think of the here and now, the present conditions. Climate is a little bit different and can be defined as general weather, and this is the important part, over a long period of time. This difference is why climate scientists like myself have a very different job than meteorologists. They're trying to predict what the weather's going to be like in an hour, or a day, or even a week. I don't do that. I'm trying to predict what the world's going to be like in 10 years, or 50 years, or even sometimes 100 years. So in conclusion, when you think about weather, really think about the short-term immediate conditions. But when you think about climate, think really long term. Awesome. So now that we've covered our basics, let's make things a little bit more difficult and introduce some numbers. I've said climate is a long-term topic, but how long? Is it a month? No. Is it a year? No. Is it a decade? Still no. It's actually defined as a 30-year average. Now, this might seem excessive, but there's a really good reason as to why we do this. And to explain why, it may be easiest if I just talk about an example. Now, I'm Canadian, and Canada is notorious for our terrible cold winters. However, about 2 years ago, for the winter of 2023, we had a really abnormally warm season. There was very little snow, and any of the snow that did come down, it melted away really rapidly. And this freaked a lot of people out. Everyone was worried about climate change. They thought this is now the new normal. Until, I guess, this year, or this winter, when Toronto got one of its worst snowfalls on record. So that is in part why climate scientists have to take such a long-term average. And that's because there's usually a lot of variation, even just year to year. Neither of those winters were typical of Toronto. So you can't use those years to estimate your climate. You have to take a 30-year average. On top of that year-to-year variation, we also have to account for some decade-long variation, because there's natural processes that affect that too. The sun, for example, goes through an 11-year-long cycle where it goes from being a little bit more bright to being a little bit less bright. And that impacts our climate just a little bit. So climate scientists have to take an even longer, and that's why we use 30 years, longer average to kind of account for those even decade-long variations. So if we go back to our good friend, the Snowball Senator, I hope it's starting to make a little bit of sense as to why I think he's confused. There are, of course, going to be variation year to year. Some years are going to be colder than others. But that's not what we mean when we talk about climate. And it's definitely not what we mean when we talk about climate change. All right, are you ready for things to get a little bit more complicated? I'm going to take your silence as a yes. So it's time to start pulling out some graphs. So this graph shows global temperatures for the entire planet. And to understand what it's trying to tell us, we do have to look at the axes. So the y-axis is actually measuring a concept known as temperature anomaly. And this can be defined as the change of temperature from a baseline. And I know these sound like big words, but the concept is pretty simple. Let's say, just for the sake of an example, that the Earth's average temperature is 15 degrees Celsius. And if we have a year that's 16 degrees Celsius, the temperature anomaly from that baseline would therefore be 1 degrees Celsius. And by the way, I am not converting this into Fahrenheit because much like red delicious apples, Fahrenheit sucks. Temperature anomaly is essentially how we talk about climate change. And you may have seen on the news recently that the world in 2024 passed 1.5 degrees Celsius of warming, right? We're measuring temperature anomaly. But that number is important for another reason. 1.5 degrees Celsius of warming is actually the target we set for ourselves in 2015 when the entire world signed the Paris Agreement. It was a nice big celebration and we all seemed so optimistic. And then immediately we all failed to reduce our emissions in any meaningful way. And we are not even close to mitigating climate change to 1.5 degrees Celsius. But that's not to say that we're going to fail, right? Even though 2024 reached 1.5 degrees Celsius, we need to remember that's not how we define climate. Again, there's year-to-year variation. So even if 1 year passes the 1.5 degrees threshold, that's not to say that we've failed, even though we're most definitely not going to mitigate it to 1.5, but the point is we haven't failed just yet. All of this is to say that climate change is clearly happening, and it's really important that we're able to distinguish what is weather, what is year-to-year variation, and what is climate, and climate change by extension. So I hope that since we've reviewed this at 3 different levels of science, that you can understand the difference now. and that you can actually now claim that you're technically smarter than a US politician. So good for you, although I don't think that's a really high bar. Well, that's it. A little bit of a shorter video, but there's really only so many ways I can tell you the difference between weather and climate. But if you like the video, give it a like. If there's something I missed or something you want me to cover next, put it in the comments below. And please, and I mean this, please subscribe. It'll help a lot as I try to get this YouTube channel off the ground. But with that being said, my name is Matthew. This has been Carbon Anonymous, and thank you for watching.